Hello everyone. In this video we would be talking about cubes, and the concept we would be talking about is coloring of cubes. For that I have taken a cube, a 4x4 cube, which is colored with red, green and yellow on two sides each, and they are the opposite sides. And we know that a cube has 6 faces, right? We know that a cube has 6 faces. So if we use 3 colors, 2 faces gets colored simultaneously. So we have 2 red faces, 2 yellow faces, and 2 green faces. Questions from this topic are very simple. They would be asking you how many cubes are, so I'll write it down. How many cubes are painted on 3 sides? The second question would be how many cubes are painted on 2 sides? The third question might end up asking you how many cubes are only painted on one side? And the fourth question would be how many cubes have no paint on them? That is 0 side painted. And by number of cubes I mean the number of smaller cubes. So since this is a 4x4x4 cube, and you can see there are 1 2 3 4 1 2 3 4 1 2 3 4, and there are 4x4x4 smaller cubes. So all these smaller cubes can be called as 1x1x1 smaller cube. So essentially it means the entire large cube that we have can be broken into 1x1x1 smaller cubes. And how many such cubes would be having? We'd be having 64 such smaller cubes. How do I know this? Now if the dimensions are 4x4x4, the volume in this case is going to be 64 units. And in this case, the volume of one such smaller cube is going to be 1 unit. So I would be having 64 smaller cubes since the volume of the entire cube does not change, right? Okay, now how does the smaller cubes are perceived? How do we get the smaller cubes? We get the smaller cubes when I cut the larger cube, the larger 4x4x4 cube into smaller 1x1x1 smaller cube. So I need to cut the entire larger cube, and that would give me the number of smaller cubes that I'm having. Now let's jump to the question and understand what is happening here. The first question, how many cubes are painted on 3 sides? Now please understand that no cube would be painted on all the 4 sides or 5 sides or 6 sides, right? You can refer to the diagram that I've taken here to understand it in a much better fashion. Okay, so how many cubes are painted on 3 sides? Now when I take these cubes, they are painted on 2 sides. When I take these cubes, they are painted on 2 sides. The only cubes that would be painted on 3 sides would be these ones. The cubes at the corner. So I have 1, 2, 3, 4 corners at the top and another 4 corners at the bottom. These 3 and 1 at the back. So a total of 8 such cubes, smaller cubes are there which are painted on all 3 sides. Now you can also take example of, let's say, a book and place it in front of you to visualize this problem in a much better way. Only the corner cubes are possible to be colored in 3 different colors, or let's say to be colored in 3 sides, not more than that. You can see that the diagram has changed. So what I've done is I took out all the 8 cubes which has 3 sides painted, right? Now this is the figure that we are having among between us. Now there were a total of 64 cubes, out of which I have taken out 8 cubes, right? I have taken out 8 such cubes out of the 64 cubes. So I am now remaining with 56 smaller cubes. Now let's move on to the smaller cubes that have two sides painted. Now which are those cubes? Those cubes are the ones that share a an edge, right? That share an edge. Let's say these ones won't be possible, but these ones would be, right? These ones would be the ones that share an edge. And we are seeing that on one edge, on any one edge, so this is one edge of the cube, on one edge there are two such smaller cubes. And how many edges do we have in a sphere? In a cube, I'm sorry. How many edges do we have in a cube? We have 1, 2, 3, 4, and at the back 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 such edges. So a total of 24 smaller cubes have two sides painted on them. Now this can be also written as n minus 2 into 12. 12 being the number of edges and n minus 2. Now what is n here? Now remember we wrote this larger cube as 4 cross 4 cross 4. So they're essentially, if I break this 4 cross 4 cross 4 into 1 cross 1 cross 1, there are essentially 4 smaller cubes on one, let's say, line of plane of on one plane, right? If I consider this as a line of plane or this as a line of plane, the total number of smaller cubes that appear on this line is nothing but the value of n. Why am I subtracting 2 from it? Because of the fact that I've already cancelled off the corner 2 cubes, and that is the reason I'm subtracting 2 from the entire line. I need to subtract 2 smaller cubes from the entire line. Had the line contained 8 total smaller cubes, I would have gotten 12 into 6, that is 8 minus 2 number of cubes, smaller cubes which had two sides painted. So whatever side you have, you need to subtract 2 just to eliminate the 2 corner cubes that would appear on each such line, on each such, I should say, edge. Now let's move on to the third part, that is the number of smaller cubes having one side painted. And which are these smaller cubes? The smaller cubes that are on the faces are these ones that have only one side painted, because the sides that are below the surface are not painted, right? So only these cubes, smaller cubes, have one side painted. Now if we consider this face, one such face of the cube, how many such smaller cubes do we have? We have 4 such smaller cubes in this case. And how many faces do we have in a cube? We have a total of 6 faces. So that gives us 24 smaller cubes having one side painted. This can be written in the form of 6, that is the number of faces, into n minus 2 whole square, where n again is equal to 4 as we discussed in the previous question. Now why n minus 2? Because if I consider a face, please understand, if I consider one such face, I'm eliminating this entire line, I'm eliminating this entire line, this entire line, this entire line. So basically I'm just taking the middle smaller cubes and not the ones that are in the boundary. So I need to reduce 2 such rows from each side, right? And that is the reason I'm writing n minus 2 into n minus 2. Now let's come on to the last point, the last question, that is the number of smaller cubes which are not painted at all, no side painted. Now this can be easily obtained if I know the total number of smaller cubes and the other 3 answers. right? You can simply subtract the other 3 from 64 to get to the answer. So this can be written as 64 minus 8 plus 24 plus 24, that is equal to 64 minus of 48 plus 8 or 56, that comes out to be 8 such smaller cubes. However, let's first discuss what is the concept behind this. Those smaller cubes which would not have any side painted would be the ones when I remove all the smaller cubes that are present on the face of the larger cube, right? So I need to erase this one, I need to erase this one, I need to eliminate all these ones, I need to eliminate all the ones that are appearing on the face. And why is it so? Only when I eliminate these smaller cubes, then I will not be having any color on the remaining pieces. So basically, almost synonymous to what we did here. From the entire larger cube, you need to chop off the upper and the lower surfaces, the upper surfaces, or let's say the surfaces from the entire large cube. Now, if you consider two opposite surfaces, let's say the upper and the lower surface, this one and the one that is below it, the opposite side, then essentially I'll have to chop these two sides, these two faces from the entire larger cube. So there was a total of n such smaller cubes, and I have to chop off two of them. Similarly, for the sides painted green, I have to chop off two from them, and from the sides painted yellow, I have to chop off two such faces from them. So essentially it comes out to be n minus 2 whole cube, where n again is what we discussed here. So if you put the value of n, it comes out to be 4 minus 2 whole cube, that comes out to be 8 directly. And this is the concept behind the number of cubes which do not have any paint on them. So let me just mark out the answers once more and run you through. 8 cubes would always be painted on 3 sides, provided that the entire larger cube is painted. The corner cubes are the only ones that can be painted on 3 sides. The number of smaller cubes that are painted on 2 sides are given by the formula 12, that is the number of edges into n minus 2. The number of smaller cubes that are having one side painted is given by the formula 6, that is the number of faces multiplied by n minus 2 whole square, because we need to chop off everything that are present at the edges. Everything that are present at the edges. And finally, we will be moving to the number of smaller cubes which no side painted. We just have to make sure of one thing, that we eliminate all the cubes that are colored. That is, we need to eliminate one layer from each of the face. We have 6 such faces. We have to eliminate one layer from each of the face. Now, if you eliminate one layer from opposite sides, essentially you are eliminating 2 layers, so that becomes n minus 2, and we have 3 such opposite sides in this cube, in any cube rather, so that would lead to n minus 2 whole cube. As a shortcut formula, I would rather say, to give you the number of smaller cubes which have no side painted. So this was all about cubes and the number and the coloring of cubes, the coloring of smaller cubes and so on. Please do solve a question on your own to understand this better. I would also ask you people to keep a book or anything that is cubical in nature, so that you people can visualize what is happening in front of you. That would really help you understand this problem in a much better way.